Okay, let's.
Nobody's.
There's only one person in the group.
Let's see, what's your favorite class in college?
That's not a class.
I think lunch is class.
No, it's not.
It's included with our third period, but, and I would. Do you know they don't include car trouble as like an excuse?
Perfect.
Like if your car breaks down on the road, which, you know, happened, they literally are like, no, that's not a you problem. I'm like, thanks guys. Same with, I had a funeral to go to, they were like, where's the doctor's note? I was like, what do you mean?
So Lexi, you used the area model to start, didn't you?
For the first one.
So why didn't you for the second one? It would have helped you organize that information.
Oh, I know what I was doing.
So, all right, I am collecting at this point.
Just saying those guys, it's just. I didn't even get to write that, I was halfway through writing psychology and
So let's quickly talk about this. So, no, that's not what I wanted to put up. This one went up. So negative 2x cubed minus 10x squared minus 6x plus 18 seems to be what I have across the board. Be careful, whoever typed this, just at least typing into the calculator, you made all of that an exponent. You have to click to the right to bring it back down. Also, and this is a common mistake I'm seeing a lot of us make that you need to be very, very, very careful about right here. If, I don't know who this was, but my guess is when they typed it into the calculator, they did minus 10x squared, but then they did a negative, not a minus, a negative 6x. Well, if you don't type anything in between here and that's a negative, the calculator is going to understand that as multiplication. So if you type that in and graph it or something like that, that's going to be very off. Even though you were very close, you just needed a minus, not a negative. So you need to be careful about that because the calculator is going to automatically multiply there. I will say this. You can. What are the two methods you can use to multiply polynomials? Distribute and the box, or the area model is what that's called. However, what I am seeing is the students who are having the most success are using the area model. It helps you organize information. It's your choice, whatever you use. Personally, if I have two binomials, I'm going to distribute, and I might move to the box or the area model in order to do something that's a trinomial to help me organize. But that is something to be aware of. Please put away any books because they are not math related. They're not going to help you learn this math. And then we're going to get frustrated because we don't know what's going on. Alright, domain intervals over which the function is decreasing. So how many domain intervals should we have where the function is decreasing? 2. We need to pay attention to that, and we need to be careful about that. But I am seeing a very important mistake that a lot of us are making. For example, right here, and I'll bring up the graph in just a second. Both of these students said infinity, comma, negative 3, and then negative 0.33, comma, negative infinity. So let me pull up the graph, and I need y'all to pay attention to this because this is on your understanding check. Why is that incorrect?
Infinity to, what did you say?
They said infinity, comma, negative 3.
I didn't get a bracket.
Do we need a bracket with domain intervals of increase or decrease? Nope. Where's the negative 3 coming from? Let me ask that.
The increase.
The little point down there. That one.
The one that touches the x-axis.
Right there, that one's on.
The minimum. You can say minimum or x-intercept. So do we all agree that it stops decreasing at that negative 3? Yes?
At that point.
It stops decreasing at negative 3. That's the maximum for the decrease. So what is the issue that I have with infinity comma negative 3?
It's. Oh, don't it decrease again?
Well, it's okay that it decreases again, that would just be a separate interval. Remember, it's not just an interval. What's the word in front of it that I keep missing that y'all don't call me out on? Domain interval. You got to remember that is a domain interval. Are you telling me that the domain value all the way up here and over here is infinity? The x value is infinity? It's negative infinity. You've got to remember that these are domain intervals over which the function is increasing or decreasing, right? So it starts to decrease over here to the far left. What x value is to the far left? Negative infinity. This infinity that the person put, which it wasn't just you, it was multiple people, that infinity is not an x value, it's not a domain value, that is the range or the y value. You've got to remember it's a domain interval over which it's increasing or decreasing. And then similar issue here, we have, do we all agree that negative 0.33 is where it starts to decrease again? Okay, so negative 0.33, comma, they put negative infinity. Is that a domain value that they're referring to? As it goes down, it's also going to the, so that should be positive infinity. You've got to remember the domain intervals are just those x values. You go with that, Jaden? Any questions about that? No? Kyla, you good with that? Jada? Lexi? Okay. And so then quickly looking at the increase, negative 3 comma negative 0.33 for the most part across the board. Notice we don't want to say it starts increasing at negative 3 and stops at this point. We just put the domain interval. We just put those x values, and so it would be increasing from negative 3 comma negative 0.33. With domain and range, we can use brackets. Do we ever use brackets when it comes to, what's it called? The domain intervals of increase and decrease. No, do not forget that. By the way, also I meant to mention this earlier, don't forget, do your distribution with your binomials, but come back and remember your negative 2 needs to be distributed at the end. I think most of us did remember that, but just make sure you're paying attention to that detail. Alright, getting into today's lesson. I believe y'all already started to cut out the graphs from yesterday to talk about increasing or exponential growth and decay. As a quick reminder, I will not be seeing any of you. Actually, I think I see Lexi and Nathan. You were in my room for the ACT stuff, but I won't see any of the rest of you tomorrow because we will have the juniors taking the ACT. You go to the same room as last time. Seniors and Cameron, y'all will be in the gym. You already have the homework assignment. It's on the desk. No one came back for it, but if you look, there is a front and back and then a front called skills practice for characteristics of polynomial functions. This is the last assignment you have for me on characteristics of polynomial functions. It is based on everything we did from the textbook. I gave you back your graphic organizers yesterday. Did you turn yours in yesterday? Come back to me today so I can give it back to you. I did not give feedback on it, but I will during my second block planning so that you can get that information.
Our graphic organizer,
The pink sheet
oh, okay.
that has the vocab terms. Oh man, I meant to make your graphic organizer a different color and I totally forgot. There should be one of those on your desk.
Well, you made it white, that's a different color than last time.
Yeah, but I try not to make it the same color as all of our other sheets. So, the skills practice is your last set of practice to help you get ready. Oh, it's right there.
Is that our homework?
Jada.
Yeah, this is.
Or is that Kyla's?
I think so. Is this the one with Thursday?
The skills practice is due on Thursday.
All of it?
Yes. Okay.
So how?
The skills practice, not the graphic organizer, just the skills practice. Okay? It is the only homework you have. And, LaShannon, you don't have a class for me. That's the only homework you have that is due this week,
Okay.
I think. I'm pretty sure it's confident. I mean, it's in the slides already. I'll have to go ahead and look. Okay, hold on, listen, okay? So, the skills practice is due on Thursday. I think that the next homework isn't due until Tuesday, if I remember correctly. I'll have to look at the slides, we'll see it at the end of the class. I did already give you your next graphic organizer. If I were you, I would stay on top of my graphic organizer and I'll tell you which terms we have covered by the end of each day. That is my goal, so that you know what you can fill out each day. And that's going to help you reflect on your lesson that night. That will help you learn better. Also, I need you to hear me very clearly on this, because this is a disconcerting thing that I saw on the most recent graphic organizer. Look at the very top. It starts out by saying definition. What comes after the word definition, though?
Major concepts.
Or major concepts and connections. And it really probably should say and. If you just give the definition, that is not going to help you very much in preparing for the test and understanding checks and all those other things to understand this math. The whole point is to show examples. That's the feedback that I keep giving y'all. Show examples. Identify every page or every lesson from the textbook or every task that goes along with that concept so that you can use this as a piece of study material. Go deeper than just a simple definition. Show all the connections. Show algebraic representation. Show graphical representations. All those sorts of things that will help you grow and learn way more. So, let's get started. We're going to hopefully knock out the getting started activity 2.1 pretty quickly so we can get to compounding growth and Euler's. Huh? Not today. That's for the whole unit. Is this late homework? So, Jada did ask a question. Y'all, there are 2 pages. No, we're not covering all these terms today. This is for the entire unit. Okay? So, this is for the entire unit. At most today, we will hopefully get to compound interest formula versus continuous exponential growth. That's 3 terms. Okay? So, stay on top of it. Try to reflect and get through those things as quickly as possible. So, remember we're trying to identify domain and range of exponential functions and make sure we understand the difference between exponential growth and decay. This is going to help us get into what are called logarithms. So yesterday, you already cut out your graphs. You should have already identified the shape that we believe is an exponential growth or decay. And we also talked about this. How are you supposed to get the points on the graph for a function like this? This is the last thing we talked about.
-1, 0, and 1 for x.
Okay? And how do we know -1, 0, and 1?
And it's on the thing right here.
What's the thing?
Table.
Right. If you look at your tables, there are those inputs. When you plug a number in, you should get a number out. That gives you a point that should be on your graph. So, work within your small groups. I want you to sort those graphs, figure out what equations go with which graphs. And the big thing is you should already know the shape for exponential growth and decay, because we talked about it yesterday, but we also want to pay attention to what graph or what equation goes with exponential growth and decay, because there are distinct differences in those 2 things. Any questions before we get started? Alright, hard cap at 10 minutes. That's all we got. Let's get to work.
I would sit down on that in both of them. So you might figure out versus is being